So in this video, we are going to be making a perfect square from expressions like this. As we can see, this is x squared plus 8x. If we were factorizing that, we would not get a perfect square. But if we were to add a term to it, we could make a perfect square. So just remind you, these are the general rules for perfect square. If you're not sure on this, you can always watch the video on perfect squares. So let's just consider what a perfect square looks like. Let's go for x plus 3 all squared. So that's currently a perfect square in factorized form. If I expand that, I get x squared plus 6x plus 9. Now let's have a look at how that's broken down with regards to the general rule. We can see that a in this case would be x, and we can see that b in this case up here is 3. So this expression is made of twice a times b. All right, so obviously a being 1 there, the coefficient, and that being 3. 2 times 3 times 1 is just 6. So we get the 6. So let's consider the original expression which I talked about at the beginning. So it was x squared plus 8x. Now let's just have a look at this 8x. We know that this is twice ab. So in order to work backwards, we know that we need to half that number and obviously then square it. So it's like half the x coefficient and then you square it. So let's just do that. Let's add half of 8. So if I write 8 over 2 squared, that hopefully is going to give me a perfect square, which in this case would be x plus 4 squared, or remember that's the same as x plus 4, x plus 4. Okay, all squared. So hopefully that will work. So let's do that. Let's just write that as x squared plus 8x plus, well, half of 8 is 4 and 4 squared is 16. Now double check that. When we expand this using FOIL, x times x is x squared plus 4x plus the 16. There's the 16 made up here. So we know that we have to add half the coefficient of x squared to make this expression a perfect square. Let's try another one. Let's try x squared plus 12x. So again, let's half and square this number. So I'm going to add 12 over 2 squared to hopefully make that a perfect square. So that becomes x squared plus 12x plus 6 squared, which is 36. So let's check it by expanding that, because we know that using the perfect square rule, that fully factorized becomes x plus 6 squared. So let's just double check for expanding it, x plus 6 squared using FOIL. All right, because we know that the perfect square method works, but I always like to double check. X squared plus 6x plus 6x is the 12x plus the 36. So we have to add half the coefficient of the 12 squared. Now I'm going to generalize this now and place it in a purple box for you to copy down. Okay, so you can see I've actually shown that this is half the coefficient of x squared, and that's what we need to add. That's the term we need to add to this expression to make it a perfect square. And over on the right here, this is now factorized to be a perfect square. So hopefully you can use that rule. Let's just do one more. X squared plus 10x. So if I'm going to use the above rule, I'm going to add 10 over 2 squared, which gives me x plus 5 all squared.